Hi everyone, we have reached the end of our June exam question paper 1, grade 10, and this is question 6, which is another graph question, but here obviously the graph has been given to us as opposed to the previous question where we needed to sketch the graph from the given equations. Here we are given the graphs and we need to determine the equations of those graphs in addition to a few other things. So let's see how that goes. Right, so let's just go through our question here. The graphs of f of x equals ax squared plus q. So f of x is ax squared plus q. That is obviously our parabola. At this point, you should identify this form here. This is the standard form of a parabola. So that points to this graph over here. And then h of x equals mx plus c. I mean, that's a straight line straight off, mx plus c, so that would be our straight line. That is given below. The graph of f cuts the x-axis at points A, for which there's no coordinates, and then B, point B, 2 and 0, which is given. And then they say f, negative 3 and 15, is a point on h, meaning on h of x on the straight line. Okay, so I won't take for granted. In fact, I think sometimes I do take for granted that when learners read this two statements that they understand exactly what is being said here. And I've come to discover that that's not always the case. So hopefully me reading through every point here makes that a bit clearer, at least in terms of what is being presented to you in this diagram. Right, so we've got the parabola. We can also see what they didn't mention in our description on top here is this point C, 0 and 12, which is basically where the parabola turns. So we know that the y value, the q value where our parabola turns is the y value here, which is 12. So we know that that is 12. So that means that q is 12. Right, so we know that already. And then there's a point of intersection here and here. So that again, if you remember from our previous question, those points of intersections are important for when we need to compare the positions of the two graphs in relation to each other. In other words, where is the one graph above the other one, etc. That's the 2 points we will use to determine that type of question. Right, let's go down to what they're asking here. So first question is write down the value of q. So that's q over here. We know that q is the turning point, the y-intercept of the parabola. So q would be equal to 12. So q is equal to 12. That's pretty straightforward. Next question. Hence determine the equation of f of x. Hence determine. Hence meaning, so from what you have gotten so far from the previous questions, in this case it's just the one question, hence determine the equation of f of x. So if I go up here, now that I have my q value, what I've got for the equation of f of x is as follows. I've got f of x currently is equal to ax squared plus 12 now, right? We have the q value, q is equal to 12, and they say from what you've gotten so far, determine the equation of f of x. Now that means I need to find the value of a. And remember we mentioned at some point previously that when we are dealing with calculations of parabolas, straight lines, etc., hyperbolas, whatever graph, even though the notation, the function notation, which is f of x, g of x, h of x, etc., that is useful for many reasons. When we are dealing with the equation itself and working out different values of the equation, we are going to let f of x equal y, because f of x is y, right? So that just means I'm going to write it as such, so that when I substitute x's and y's, or x values and y values, it is just easier to work with. You know, I don't want to work with f of x in these cases, right? So if I look at this, I need a value for a, right? And because I already have a value for q, if I could find a point on the graph that I can substitute for, remember the y and the x in this equation are variables, right? That is why they are not constants. That's y and x is not like a. A is a constant. I need to find this constant because it stays that, right? For this particular graph, a will be whatever it is, and q will be 12 forever for this type of graph, or for this particular graph, it will not change. But the y and the x's, they change. So I can choose any point on the graph to substitute into x and y. That's what I'm getting at, right? So any point on my graph is any x, y value I can substitute into this equation, then my only unknown will be a, and then I can find a. So if I go to my graph, my parabola, careful of course, f is not on the parabola, it's on the straight line, so I can't use that point. But I do have a couple of points. So I've got C, that's a point on the parabola, and I've got point B as well. That point of intersection of the two lines, that's 2 and 0. That point lies on both the parabola and the straight line. I'll use B, 2 and 0. So I'm going to substitute. So I'm just putting it in brackets there with the colon to show that what's going to happen next is I'm going to substitute. Where there's a y, I'm going to put 0. And where there's an x, I'm going to put 2. And now I can solve for a. So this is 0 equals, that's 4a plus 12. So 4a equals negative 12. So a equals negative 3. Okay, so that's just quickly, a is negative 3. So what does that mean? This means that y is equal to negative 3 x squared plus 12, which means that f of x is equal to negative 3 x squared plus 12. Right, if you didn't still write this down, this is fine because the equation of the parabola is this. These are the same thing. I just wanted to write it as f of x. Right, so the equation for our parabola is negative 3x plus 12. 6.1.3. Write down the coordinates of the x-intercept of f at point A. The coordinates of the x-intercept of f is the parabola at A. So they want the coordinates, right? They want the coordinates of that x-intercept. Okay, so this is... Okay, so this is quite straightforward when it comes to parabolas that in grade 10, for our purposes, where our parabola is symmetrical about the y-axis. In other words, this y-axis cuts our parabola straight down the middle. So it's symmetrical about the y-axis. So why that's useful is because my roots will always be the negative and positive of the same number, so the additive inverses. So if the root here is 2 and 0, then this root will be negative 2 and 0. So I can read that straight off the diagram. Notice it is 1 mark, so there is really no calculation to do here. So I'm simply going to write there my a is negative 2 and 0. That's all I need to do. (6.1.4) Determine the value of m, the gradient of h of x. Right, so h of x, remember, is our straight line. So standard form mx plus c, gradient is m. So for the gradient of a straight line, I need at least 2 points. If there's no other way of getting that gradient, in this case, that's the only way I can get this gradient, is if I have 2 points and use the gradient formula. So if I look at my straight line closely, my straight line has this point B, 2 and 0, because that's on the straight line, and it has point F, right? So I've got 2 points on my straight line, so I can easily work out that gradient. So I can say that m is equal to y2 minus y1, we know the story, over x2 minus x1. And if I go back to my diagram, I'm going to label f as x1, y1, and I'll label this as x2, y2. So y2 is 0, and y1 is, that was 15. Right, so it's 0 minus 15. Then x2 was 2, and x1 was negative 3. So that's negative 3. Be careful here once again of the signs. That is mostly why we get this wrong, because we forget about the negative signs. So this simplifies to negative 15 over, that's 2 minus 3 is 2 plus 3, which is 5. So that's negative 15 over 5, which gives us negative 3. So our gradient is negative 3. And that was what they asked of us. Determine the value of m, the gradient of h of x. 6.1.5, hence again determine the equation of h of x. So for h of x, just write here 6.1.5. Currently we have h of x equal to mx plus c. We know m is negative 3 from our previous question. That's negative 3x plus our c. And once again, I'm going to let h of x equal y. So I can write it like this. So now I can substitute a point in here, and I can see clearly what I'm doing. So again, like before, same explanation like before. The y and the x here are variables, but my m and my c are constants. So I can choose any xy point and substitute it in here if that point is lying on the graph. So I know on my straight line I've got 2 points. I've got F and I've got B. I'll choose point B. That's more of a simple, because that's an easy point to use. It's 2 and 0. So 2 and 0, again, I've got 0 equals negative 3, and x here is 2 plus c. So 0 equals negative 6 plus c. So c equals 6. And what does that feel familiar? Did they give us? No, they didn't give us point D. So c is equal to 6. So therefore, y is equal to negative 3x plus 6. That means h of x is equal to negative 3x plus 6. And that is our equation for h of x.